This video will outline how to use Solidworks surfaces. Using this very irregular genie lamp, we will show you many of the features, and then some of the features that are not covered with this part will be shown with a separate part. Opening up the genie lamp part, you can access surfaces by right-clicking on the toolbar and selecting surfaces under features. It'll appear in your left toolbar. The first four features are very similar to the standard features, such as an extruded surface, revolved surface, a sweep, and a loft. To make our genie lamp, the body was made out of a revolved surface. So as you can see, we drew our wire revolve frame, and it revolved around this center axis, like you would in any normal feature. However, it assumes it's a surface, so it is hollow, and this opening allows for this to be filled. Next, we did the spout of the genie lamp. This we used a loft for, and as the revolve, it assumes it is a hollow surface. So for the loft, we drew our two end conditions. This is a half ellipse, and then a half circle on this plane. And then we drew these guidelines so that the loft knew how to follow. You can see the surfaces allows for this kind of distorted shape, and it is hollow on the inside. We then mirrored that loft against the front plane and created this full tube-like loft. A bonus of surfaces is it takes care of these end conditions. You can address them in each of your features so that there isn't a point here. It's a rather smooth transition, and you can't really tell that we actually mirrored a feature. Attaching the spout to the body, we used a fillet. A benefit of using a fillet is it not only smooths this transition, but it also cuts or clips this spout. It did go all the way to the center plane where we drew it on. It also clips it and cuts out the inside, so now you can essentially pour a liquid out of it. That's a feature in surfaces, only in surfaces, where the fillet takes care of that transition. Finally, we created the handle by using a surface sweep. We drew these two profiles and then a curved line, a spline, creating this interesting shape. As you can see, it creates this tube-like profile, and at these corners where it kind of pinches, surfaces take care of these interesting geometry. Another cool aspect of surfaces is how you can patch your parts. So if you have an awkwardly shaped gap with disconnecting components, you can patch it up, and surfaces can figure out all the geometry required to do that. So for example, I drew this awkward spline shape on this front plane. I'm going to extrude the surface out to about 6 inches, so it goes just past the body. And then I am going to trim this surface. So we are going to, the trim tool is this, and what we're trimming is this. We're going to keep that section. It creates this void on the inside. That's cool for one, so you have this kind of spout. You can also trim the inside so it's just a perfect exit. Now let's say we want to patch that. Let's say that is not supposed to be there. There's a couple ways to do that. One is a boundary surface can be used, a filled surface, or an untrimmed surface. These are all applicable to somewhat similar applications. We're going to use a filled surface. So what you do is select what you want to fill. Now as you can see, this is the mesh that surface is created. This is how it will fill in your gap, so it can follow some very intricate shapes and calculate how best to meet these end conditions. We'll accept that, and you can see it's a pretty accurate fill. I'm now going to start a new part to show another feature of surfaces that I didn't show on the genie lamp. So we'll start by drawing a basic rectangle and making it a planar surface. So as it says, it's just a plain metal looking surface. We'll create another rectangle on an adjacent plane, have it cross through it, make that also a planar surface. And we will now use the freeform tool, which in my opinion is the coolest tool on surfaces. So you select the face that you want to freeform, and there's a lot of different variations you can play with on how it molds. You can alter the mesh density, kind of like in FEA, And also these end conditions determine that these edges will not change, also similar to end conditions in FEA. You can also apply symmetry. So I will apply direction 1 symmetry, meaning what happens on this side happens on this side. Now, you add curves, and this tells your part where it will move. You select these little arrows, then you can morph it in different directions. You can see it's symmetrical, so what happens on this side happens on this side. Gives a very, very cool organic shapes, and this is how you can achieve some really interesting car bodies, or if you want to model parts of nature or hills, something like that. So we'll do the same on this part. We'll add some curves. And we will deform this one as well. So you'll notice these two shapes have this very intricate interface where they meet. Surfaces is able to trim this without fail. So you will go to the trim feature, and you will select what you want to trim. So let's say we want to trim this part. This is what the trim tool, and this is what we want to trim. And now you can see this perfect connection between the two parts is achieved with these very organic shapes. For this final clip illustrating surfaces in Solidworks, we have two planes. One has been freeformed, and we'll show you two features that haven't yet been covered. Just to show you a bit more about the freeform, when you enter it, I mentioned earlier these are the end conditions. These can be changed based on what shapes you have beyond them. For example, you can make this tangent. You can see it changed the curve so that these are now tangent to that line. So if there were another surface here, it would be continuous. We'll keep them as contact for this demonstration. So the first feature we will show you is the boundary surface. This creates a boundary between two profiles in two directions. So for this, you select your two profiles. Let's say we want to connect this line to this line. It will follow these two profiles and connect your surfaces as such. So this is very similar to the patch tool, except these are two freestanding surfaces that are not connected. Another tool we will use is the extend tool. This one's cool because it follows the exact same curve that the shape had been in. So for example, all the curve lines of your freeform are continued as long as you want. So you can do up to a surface if you want to connect to this surface. And it'll connect up to this in the same smooth lines. Or you can do a distance. So if you want to go 0.5 inches down, it can continue all the way down like that and maintain the same organic shape.